Okay, grade 12, here are a couple more examples, okay. In the first one, they ask me to prove that the sine of 2x minus the tan of x all over the cos of 2x is equal to the tan of x, okay. All right. And then they also ask me for which values of x, for which values of x is the identity undefined. Now remember, the only time in maths that something is undefined is when the denominator is equal to 0. All right, but let's go back to actually solving it again. All right, my left-hand side looks harder than my right-hand side, so I'm going to start with my left-hand side. Sine 2x, I only have one option. It's 2 sine x cos x, okay? Minus, as soon as I see a tan, I know I'm going to write that as sine x over cos x. Okay, now at the bottom, I've got a couple of options, okay? All right? And I might try one and it doesn't work, okay? Don't give up. Then go back and do the next one and then do the next one, okay? All right, I'm just for now going to keep it as cos 2x because I don't know where I'm going. Okay, on top now, I can take out a common factor of sine x. So if I take out sine x, I'm left with 2 cos x minus 1 over cos x all over the cos of 2x. Okay, now within the bracket, I can see that I can find a common denominator. So within this bracket, I'm going to find a common denominator of cos x, which means that I'm left with 2 cos squared x minus 1, which is now going to help me choose, because I know that cos 2x can be rewritten as 2 cos squared x minus 1. Okay. All right, so remember here, what am I really doing? I'm dividing by a fraction. So I'm going to write it as sine x times 2 cos squared x minus 1 all over cos x. And then I'm going to times by 1 over 2 cos squared x minus 1. Okay? That and that will cancel, and I'm left with sine x over cos x, which we know is equal to the tan of x, which is equal to my right-hand side. Okay, all right. Okay, I'm going to squeeze in on the side here for which values of x is the identity undefined. So if I look at my original, okay, in my original, you happy I've got a denominator of cos 2x. So I'm going to let cos 2x equal 0. All right, now whenever you're dealing with these sorts of things, think about what your cos graph would look like. If you had a cos 2x, are you happy that you would have two graphs fitting into 360 degrees? Okay, so it would be 0 at 90, and it would be 0. Oh, I'm going crazy. Hang on. No, it would be. All right, I've got two graphs going in there, okay? All right, so normally this would go up to 180, agreed? Okay? I'm confusing myself with the graph. I'm sorry. Let me just erase that. All right, so I'm going to say cos 2x is not allowed to equal 0, okay? And also, as soon as I've got a tan, I know that the tan of x is not allowed to be equal to 0, okay? All right, so let's just think of a normal cos graph. A normal cos graph, is going to equal 0 at 90 and 270. So here I'm going to say 2x is equal to 90 degrees plus 360k, where k is an element of integers, okay? Or 2x is equal to 270 degrees plus 360k, where k is an element of integers, okay? If I just carry that on, x is equal to 45 degrees plus 180k, where k is an element of integers, and that will give me the general solution. And here I'm going to get x is equal to 135 degrees plus, sorry, this pen's going funny, plus 180k, where k is an element of integers, and that will give me the general solution. Agreed? Okay. All right, now if you think of tan, okay, where is tan not equal to naught? Think of your tan graph. Okay, your tan graph is equal to naught when x is equal to 0 degrees. Okay, and here think of your tan graph. Okay, and then it repeats itself every 180 degrees. So it'd be 0 degrees plus 180k, where k is an element of integers. So those would be your three general solutions, okay, for which values of x is it undefined. Obviously, if they now asked you between negative 360 and 360, you would have to go and give them all the answers, okay? All right. Okay, let's go on to one more. Number 2. Number 2. All right, here they say to me that they want me to prove that cos 2x all over cos x plus sine x cubed is equal to cos x minus sine x all over 1 plus sine 2x. Okay, so I don't get a heart attack, okay, because it's cubed, all right? I leave it as it is and I think, right, what can I do? Okay, all right, I know on my left-hand side cos 2x, okay, I can rewrite as cos squared minus sine squared. And then surely I could factorize that and maybe eliminate one of the denominators. So I'm going to write this as cos squared x minus sine squared x all over cos x plus sine x, okay, to the power of 3, which is equal to cos x plus sine x, difference of squares, and cos x minus sine x all over the cos of x plus the sine of x cubed. Okay, so now at least I know that and that will cancel. All right, so I'm left with cos x minus sine x all over. Now I'm going to expand the bottom and I'm going to get cos squared x plus 2 cos x sine x plus sine squared x. Okay, and you should be able to recognize in there that you've got cos squared x plus sine squared x, and cos squared x plus sine squared x is going to give you 1. So you've got cos x minus sine x on top, and at the bottom you've got 1 plus 2 cos x sine x. And 2 cos x sine x you should recognize cos x minus sine x is you should recognize as sine 2x, which is therefore equal to your right-hand side. Okay.